Okay. This is number 2, part E, and it says 2 pieces to it. We have a ladder that's 20 feet long. It leans against the side of a building. The angle between the ladder and the building is 22 degrees. The first thing they want us to do is to approximate the distance from the bottom of the ladder to the building. I know I need to draw a picture to understand this better. What does my picture need to have in it? Needs to have a ladder. Tell me what that ladder looks like. Slanted, it's going to be the hypotenuse, and it's leaning up against what? Side of a building. So here's our building. And we've got our ladder leaning up against it. All right, what else do I know? Or what else would I need to include in my picture? Ladder is 20 feet long. What else? What'd you say? So where does that go in my picture? I agree that that needs to go there. Up in the top. So 22 degrees. And what are we wanting to determine about this? The bottom. Yep. This right down here. And that's going to form a right angle with the building as long as the building was constructed correctly, right? This is what we're looking for. What trig function will help me do that? Sine. So I'm going to have sine of 22 degrees is equal to what? X over 20 feet. All right. I want to solve this for x. So how do I do that? Multiply both sides by 20 feet. So grab your calculators and let's do that. And go ahead and round it out to 2 decimal places for me right now. .49 feet. All right. Second part of the question. If the distance from the bottom of the ladder to the building is increased by 3 feet, approximately how far does the top of the ladder move down the building? What in the world are we trying to find? Which one?
The long leg.
The long leg. What's happening to this ladder?
Moving like that.
Yeah, it's going to start like this, and then it's going to slide down the wall. So I'm going to kind of draw the 2 positions of this ladder here. Ladder starts off like this. And then it slides down the wall to about here. And what we are wanting to know about it is the amount that it slides down. Does that make sense? Do you guys understand what we're talking about here and what I'm looking for? So now we need to figure out how can we determine that. What kinds of information do I have access to that would allow me to figure out how much it actually slid? What did you say, Nicole?
How it increased by 3 feet.
The bottom increased by 3 feet. So right here is 3 feet added on to whatever was there before, right? What was there before? 7.49 feet. So across the bottom, it's 10.49 feet. Okay? I agree that that is useful information. What else is going to be useful in helping me figure this out? Length of the ladder. Does that change? Length of the ladder stays 20 feet no matter what. And this building is still making a right angle with the ground because the building and the ground didn't move at all. Okay. What else can we use to our advantage? What can I use the length of the ladder and this 10.49 feet to help me figure out? Yeah. I can figure out this height right here, right? Are you guys okay if we call that y? So how can I use the 10.49 feet and the length of the ladder, 20 feet, to help me figure out y?
Use the inverse.
What? Inverse of what?
Sine.
Inverse of sine. Okay, so it'd be inverse sine of what?
10.49 over 20.
Inverse sine of 10.49 over 20. Okay. What is inverse sine of 10.49 over 20?
31.63 degrees.
You said 31.63?
Yeah.
So what is 31.63 degrees?
The angle.
So what you just helped me find is this right here, right? Okay, so that's 31.63 degrees. So now how do I find y?
You can use cosine.
We can use cosine, right? By the way, is this the only way that I can figure out how big y is? What else could I use? What we're doing is fine, but what else could I use? We could use Pythagorean Theorem, because we had one side and we had another side, and we needed the third side. Same thing either way. We might be off by like 0.001 decimal points. Not worried about that. But yes, you can use Pythagorean Theorem, or you can find the angle and then use cosine. Because as that ladder slides, that angle is not going to stay 22 degrees. Okay, so we do cosine of 31.63 degrees equals what? Y over what? 20. Because that hypotenuse stayed 20 feet. The ladder stayed 20 feet long. So then how do I find y? Yep. Multiply both sides by 20 feet. So y is approximately how big?
17.03.
You said 17 point what? 03. I just couldn't hear the last digit. My apologies. 17.03 feet. Does that answer the question? No. That's how high up the wall it is right now. I want to know how much it slid. So what other piece of information do I still need? I need the original height. This is height of ladder after it slid. How do I find the original height?
Because 22 equals x over 20.
Yes. For the original height, we have the cosine of 22 degrees, because that was our original angle, equals, I'm going to call this one h instead of x or y, since I already used x and y for other things. Are you guys okay if I call it h? Okay. So I'm calling this right here h. H over 20 feet. So then I multiply both sides by 20 feet. What was the original height?
18.54 feet.
18.54 feet. So how do I find the amount that it slid?
Subtraction by 17.53.
Yes. I've got 18.54 minus 17.03 feet. How far did it slide? 1.51 feet. Absolutely correct. Where did I put my note? There we go. 1.51 feet down. I'm actually going to scoot this up just a little bit higher. Okay. We are going to kind of switch gears a little bit. We're still going to be solving problems, but we're going to use something that I don't know if you guys have ever been exposed to before. It's called bearings. Do you guys know what bearings are? It has to do with navigation. Have you guys ever seen how ships navigate or how airplanes navigate? Any ideas? So it looks like an XY axis, and then it has like these little circles that go out from it. They usually will describe their location either in the water or in the air in terms of where they are in relationship to a north-south line. So bearings get used in navigation and sometimes in surveying. So, huh? Yes. This is what radar uses, what sonar uses, yes. You have to worry about a third plane when you're talking about like depths and stuff in addition to, left, right, back, and forth, but yes. The direction or bearing from the origin to a point is stated by specifying the acute angle. Acute means what? Smaller than 90. So some angle smaller than 90, that segment from the origin to point P makes with a north-south line. This is where bearings are really, really different than everything else we've talked about in this unit. And this is where bearings tend to throw people off. When we've talked about the unit circle, when we've talked about measuring angles, when we've talked about reference angles, it was all in relationship to which axis? The x-axis. We always talked about things in relationship to the x-axis. But when they talk about bearings, they talk about their relationship to a north-south line. So we have to think about it slightly differently. When you talk about a bearing, we don't only want the angle, we need directions that go with it. We need to know whether that point that we're moving towards is north or south of where we currently are, and is it east or west of where we currently are. So I need the degrees in reference to a north-south line, and then I need to know which way I'm going from there. We're going to do a couple examples here. So if I have a point right here, I'm going to call this point A. When you're in an airplane, when you're on a ship, it's always assumed that you are at the origin. And you move in relationship to that. So I'm going to draw a straight line from where I'm at, the origin, to that point A. This angle right here, again, from the y-axis, from this north-south line, let's just pretend that this is 25 degrees. The bearing of that point from where I am at the origin, first of all, is that point A north or south of the origin?
North.
North. So I would write it as N for north. And then I'm going to put the angle, 25 degrees. Is that point P east or west of the origin? East. So north, 25 degrees east is how I would write the bearing for that point A. Let's try another one. I'm going to call this point B. First thing I'm going to do is draw a line from the origin to that point. And then I want to make an angle between that line segment that I just drew and what? On my y-axis. I want to know what is its relationship, how far away from the y-axis, from that north-south line. We're going to pretend that this is 70 degrees. So far, so good? So now I need to give the bearing. Am I north or south of the origin? North. How many degrees do I move away from that? 70 degrees. To the east or to the west? West. So that's my bearing for point B. Let's do a couple more. We're going to call this point C. What's the first thing I do? Make a line. And then what angle am I interested in?
From S to C.
Yes. Right here. We're going to pretend that that's 40 degrees. So what is the bearing to get from the origin to point C? South. 40 degrees. West. Yes. Let's do one more. I want you guys to try this one on your own. This is point D. And I'm going to tell you that this angle right here is 55 degrees. I want the bearing to get from where I am at the origin to point D.
55 degrees east.
Yes. South, 55 degrees east. So far, so good? Okay. Let's try some problems that involve bearings now. Okay? We're going to do about 3 problems today. We'll do the rest when I get back on Thursday. I won't be here tomorrow. I have a full day of professional development. I have a student teacher that teaches all except my dual credit classes. She will be the one that's in here with you guys tomorrow. So she's familiar with my room. She's familiar with my policies. She just doesn't know everybody's names yet. I will leave you, or leave her, and she will give to you a study guide so that you guys can begin preparing for the test. Because the only thing that we still need to do is just a couple more example problems with bearings after this. And then we're done with this chapter. All right. A plane is 80 miles south and 95 miles east of Cleveland. What bearing should be taken to fly directly to the airport? Now, they didn't say this, although I think they should have. When it says that it's flying to the airport, where do you think that airport is located? What city?
Cleveland.
It's in Cleveland. They should have said that. All right. So if this is my airplane, don't laugh at my bad whale art. There's my happy little airplane. Where would Cleveland be in relationship to that airplane?
Me up and then to the right.
Yep. So Cleveland is like here, right? It'd be to the left.
Yeah.
Yep. So I'm going to have to redraw my airplane. So Cleveland is here. My bad art just goes on for days. What do we know about the relationship between the airplane and Cleveland? 80 miles south, so if I drop a straight line like this, that would be 80 miles. What else do I know? 95 miles to the east, so this way. And that's going to make a right angle, correct? What is it that I'm wanting to know? So who wants this bearing? The pilot. Remember when we were just talking about bearings and I said, like, wherever you are, whatever ship you're on, whether it's an airline or whether it's a boat, you are at the origin. So the origin is where this airplane is. So this is how the pilot is seeing that. So far, so good? So here's north and south, east and west to the pilot. So there's a couple things that we already know about this bearing, don't we? Is the pilot going to have to go north or south? North. Is the pilot going to have to go east or west? West. So I know this much about the bearing already, and now I still need this angle. Where is the angle that we're looking for in this picture? Right in front of the plane. So like here? Why not?
Because it's the bearing, so it's in relation to the north-south line.
Yep. We want this angle right here. That is the bearing that the pilot will take. So I'm going to call that alpha. How can I figure that out?
You can find the inside and then subtract.
Subtract from what?
I did 90.
Yep. So I'm going to call this one down here theta. You guys okay with that? We're going to find theta, and then we're going to do 90 minus theta. So alpha is equal to 90 minus theta. How can I find theta then?
The inverse of tan.
Inverse of tangent. So inverse tangent of what?
80 over 95.
80 over 95. So how big is theta?
40.1.
40.1. So if alpha is equal to 90 degrees minus 40.1 degrees, how big is alpha?
49.9.
49.9. So what is the bearing that the pilot needs to take?
North 49.9 degrees
North
east.
49.9 degrees west, yes. Before we look at any other problems, what questions do you guys have from here? How are we doing? It's really, really important that you remember when we're talking about a bearing, you are the one that is on the airplane. You are the one that's on the boat. And so when you're thinking about that, you are at the origin of your own little XY axis. And you're trying to figure out the angle that you would need that it makes with your north-south line. Okay? Because you are the navigator. You guys want to try another one with me? Everybody is so quiet today. It's only Tuesday. A ship leaves port and sails 12 miles due west. It then turns and heads north for 20 miles. At this point, what bearing will the ship take to return to port? What do I need in my picture? What all do I need in my picture?
Ship.
I need a ship, okay. Anything else I need?
20 miles
20 miles north.
north.
Oops. And 12 miles west. All right, so here's my boat. So what is this right here?
The origin.
The origin? It might be. We went 20 miles north and 12 miles west of what? Of port. That's port. Remember, we are taking the origin and moving it with us. Wherever we are is where the origin is. Because we are the ones with the navigation tools. What else can I fill in this picture? I think I missed a couple things. I know that's going to make a right angle. Is there anything else that I need in my picture?
The miles.
The miles. Okay. So what do I fill in? What should I put across the top? Right here.
12 miles.
12 miles. So what do I put over here?
20 miles.
20 miles. What do we want to do? What's the ship trying to do? Find the bearing back to port. Okay, so ship wants to go back to port, but the ship is the one with the navigation tools. So tell me the parts of the bearing that we already know. From where the ship is right now, what way is it going to have to head? I heard south and I heard east, absolutely. Which part comes first in bearing?
South.
South. So this is south, some angle, and then east. What's the angle that I'm looking for? Hmm?
Close to the y-axis.
Close to the y-axis. So this right here is what I want. This angle right here is my bearing. Are you guys okay if we call this one beta? How can I find beta then? I can do the inverse of tan again. What would that tell me if I do the inverse of tan?
It will tell you the inside.
It's going to give us the inside angle right here.
Could you flip it, the numbers? Or no?
Could we flip the numbers? What do you mean?
Like, make, because I'm like kind of drawing another triangle, and so the opposite side will be the 20, and then the adjacent side will be the 12.
So if you drew another triangle, I think I see what you're saying. Like if you read the directions leaving from port and going like this, and then up like this, then you're right. This is going to be 12 miles. And this over here, let me scoot my picture over. There we go. This would be 20 miles. Now if I find the tangent of that, that is my bearing, right?
Yeah.
Okay, so we don't even need the alpha if we do it like that. Cut. So inverse tangent of what?
12 over 20.
Yes. Of 12 over 20. Can you always redraw triangles like that? Yes, you can. Absolutely, you can. So how big is our angle beta? Take me out to 3 decimal places for this.
30.963.
You said 963?
Yeah, 30.
Oh, 30.963. My bad.
Sorry.
Oh, you said 964?
964.
Okay. Can you guys help me put that in degrees, minutes, seconds? Because this here is where they actually use degrees, minutes, seconds. It's when they're giving directions with bearings. I know it's going to be 30 degrees something. How many minutes?
I got 57.
57 minutes. So 30 degrees, 57 minutes, 50 seconds. Yep. Because we get 57 point what? 57.4? Hold on.
0.84.
Yeah, 0.84. 57.84. So we have 57 minutes. And then we do that 0.84 minutes times 60. And you get what, 50.4 seconds. And we always round to the nearest second. So since it's a 0.4, we're just going to cut it off at that point. I probably should have done that in a different color. but I didn't. There. If they didn't ask for exact degrees, minutes, seconds, we could have done 30.964 south, 30.964 east, and that would be my bearing. If we're going to do exact degrees, minutes, seconds, then we need 3 decimal places and we'll convert it. You guys okay with that so far? Let's do one more problem today and then we will shut it down. Sound like a plan? Okay. An airplane is 30 miles northeast from the airport. If the angle of depression from the plane to the airport's runway is 32.5 degrees, then what is the plane's altitude? What are the things I need in my picture?
Airplane is 30 miles northeast.
I need an airplane. You said that's 30 miles northeast. All right, I got my airplane. It's amazing, as always. What else do I need? I need the airport, right? Where's the airport in relationship to my airplane?
Southwest.
It is southwest. So we've got our runway here. The plane is flying along like this. Oop, not like that. I can't draw a straight line all of a sudden. There we go. What does the plane want to do? It wants to descend. It wants to land. So we're wanting to come down like this. What else do I know?
Angle of depression is 3.5.
Where's the angle of depression?
The airplane.
From here to here. So from the pilot's point of view, it's how far down he would need to look. That's my angle of depression. 32.5 degrees. So where do I put that 30 miles northeast?
Will you put on the purple one? On that purple one?
Yep. $30 miles. And what do we want to know?
How high up the plane is?
How high up the plane is. So like this, right? Do you guys see anywhere else that I could draw that same vertical line that I can make use of the angle that they gave me?
The end of the airplane.
Yeah. Right here would give me that same height. Like if the plane just keeps flying at that altitude right over the airport. So that's what we're looking for right there. So we're going to call that X. So what do I need to use to figure that out? Sine. Sine of 32.5 degrees is equal to what? X over 30. So then to solve it,
32.5 times 30.
yep. We're going to multiply both sides by 30 miles, so sine of 32.5 degrees times 30 miles. Let's take it out to 3 decimal places. 16.119. What kind of units do we need with that? Miles. I think on your homework, I was nice and I put the units in for you guys on the story problems, but on the test, any story problems, you've got to include the units. If you don't include units on story problems, it will ding you for points. So please make sure on word problems you're taking the time to do that. 6-7 homework is due Thursday night. So tomorrow you guys will work on beginning to review individually for the test. I'm fine if you guys want to work in partners or small groups, and I'll make sure that my student teacher knows that. I do have a couple books up here because some of the review problems will come straight out of the book for you guys to work on, and then some of them will be printed on a page for you. Also, if you have not done so already, if you plan on taking this class for dual credit, but you had this class first semester, you still have to sign up again. So if you have not done that yet, you need to sign up again. They should have sent you an email. I'll see if I can't find the directions from the advisor and have those printed for you guys, because that's something else you can take care of during class time tomorrow, as long as you have it. Yes, Pedro?
You just need a seat.
Huh?